Hello friends, welcome to my channel. In this video, we are going to learn about Singleton Design Pattern. When we are talking about the design pattern in any language, specifically in Java, Singleton Design Pattern is one of the most important and most common topic, which will be like very common in all of the interviews. Even if you are a beginner, fresher, or you are experienced developer, but Singleton Design Pattern is something which you must need to know. So I have prepared this video for you guys where I will cover about everything about the Singleton Design Pattern. I will also cover, if I go to the table of content in detail, I will cover what is Singleton Design Pattern and why we need to use the Singleton Design Pattern, what is exactly the need of Singleton Design Pattern. I will also cover like how we can create a Singleton Design Pattern in Java with some practical examples, and actually this complete video is based on practical examples only. So whatever I have written in the table of content, everything we are going to do in practical way in our code in Java. So next I'm going to cover even after creating a singleton design pattern class, there are some very important questions which are very quite famous these days in the singleton design pattern, which interviewers used to ask that even if you have created a singleton class, now can you ensure that class is thread safe or not? Like in the multi-threaded environment, can this singleton pattern be broken? Like, can you still create multiple objects even it should not allow it? So I will cover that part too. I will also cover one new singleton design pattern strategy, which we call it as a Bill Pugh Singleton. It was actually introduced by Dr. William Pugh. That's why we call it as Bill Pugh Singleton pattern. Apart from that, we are here also going to talk about how we can actually break the singleton design pattern. So this is also one of the very much important interview question where people ask, interviewers ask that is there a way that we can break singleton design pattern? So we are going to cover that, and we are not going to cover only one way. We will going to cover multiple ways using which we can actually break the singleton design pattern. Some of the examples of the reflection API, deserialization and serialization method, and you can see a clone. Via clone we can also break the singleton design pattern, and we will also learn about how we can prevent this breaking. So but we are going to learn all these points line by line with some practical examples which I am going to cover in our IDE that I'm going to use as Eclipse. So now let's start with the practical part, which will be much more interesting than this. So let's move to our IDE Eclipse. So I have opened Eclipse. Now I just need to create a new Java project. So I go to Eclipse and file new Java project, and let me give some name like my singleton example. I can give any name to the project, and I just created a project. And here I will I will create classes, whatever I will require. But before that, let's go back to the slide for a moment, and yeah, here we go. So first, let's talk about what is singleton design pattern. So as you can read on the screen, the singleton design pattern ensures that only one instance of a class is created throughout the lifetime of an application, and it provides a global access point to that instance. Its meaning is quite simple that, for example, if you create a class in Java, you can create multiple instances of that class by using new keyword. So, but there are cases when you will require that don't want to create a new object every time to access something, to do something. You want that only one object, one instance will be created, and the same instance will be used to do all the operations throughout the lifetime of the application. So in those cases, we want that we will create our class in a way that no one will be able to create multiple instances of that object. So if we talk about the practical examples, when exactly it will be needed, So very common example which we can think of and everyone knows it is in the case of database connection. Let's say we are using JDBC and we are creating a one database connection, and I want to perform a lot of operations. So maybe I want to perform some insert operation, then some read operation, and then some update option operation. And there is no requirement that I need to create the database connection, different database connection every time. What I can do, I can create one database connection instance, and I will use that database connection instance to perform all this multiple operation. So this is a very one common example where we actually require our singleton design pattern. There are other examples for singleton design pattern. You can see here in the screen as logger. It's a database connection pool I have already mentioned. Then you can see the example like configuration manager, then cache manager, service registry. So these are all example are something which we will use very frequently in our code, like logger. It will be used everywhere in the code, but you don't want to create a new instance of logger everywhere in every method or in every class. So to prevent these, we have this singleton design pattern. So let's go back to our Eclipse and we will see that how exactly we will can create a singleton design pattern class. So let's say I go to my source folder, I just create a class called, let me give some name. So I have given my singleton and I have given the package name as com dot my channel name, that is Krishna Bhavna. So I have created a class. And in this class, I have created a public class my singleton. And let me create one more class, which I can say it is a main class where we will have public static void main method. We will use this class for that testing purpose. So let's say if I want to create an object of my singleton class, what I will do, I will simply do my singleton. Let's say obj1 equal to new my singleton. And if I want to create one more object, I can do my singleton obj2 is equal to my singleton. And in this case, normally it is normal my singleton class. If I will create two instances of it, it will actually create the two instances. And let's say I will add our constructor to this class as public constructor, and I will simply print something just for sake of printing, that it will print that what is happening. So I have printed constructor called system.out.println. In this main.java, when I run this file, you will see the output. Output is constructor called, constructor called. Like I have created two instances, two times constructor gets called and two instances are created. And if I, there's one more thing I want to do here. I have written like obj1 dot hash code. And in next line, I am printing obj2 dot hash code. And if I will run this program again, you can see there in obj1 hash code and obj2 hash code are actually different. So this is a proof that right now we are creating two objects and both objects have different hash code. Both are taking a different space in memory. But this is something which I want to avoid. So what I will do, that we are going to see in this example. So I'm going to back to my singleton.java, and very first thing, that if someone want to create object of my class, they need to write my singleton. So it is something like we are calling the constructor of our class. So very first thing, I don't want anyone to create object of my class directly. Otherwise, it will be able to create multiple instances. So what I'm going to do, I am going to make my constructor private. So as soon as I will make my constructor private, what will happen? As you know that private things cannot be accessed outside the class. So you can see that in main we are now getting the error that you cannot create my singleton object because the constructor is not visible, it's private. So obviously I have to remove this line. I can't do this now, right? So but the thing is, if I cannot do this now, I cannot create a stance of that class, then how should I create? So the thing is, like, private can be accessed only within the class. So let's say what I'm gonna do, I am gonna create a private static my singleton obj equal to new my singleton. So if I will do, I can create the object inside my singleton class only, and let me create another public method with public static method which can be directly accessed via class name. I don't need an object or a stamp to actually call this method, and let me give any name. You can give any name. I am giving get instance. You can give get my singleton, get my object, whatever you want. And what I'm gonna do, oh sorry, I have moved the return type here. I'm gonna add return type here, and I'm gonna do just return obj. So as soon as I have written this, what will happen? Like I can not create object of my singleton class like this because my singleton constructor is still private. But what can I do? Instead of writing this, I will write my singleton and dot get instance. So as soon as I write date my singleton dot get instance, what will happen? It will come here. It is a static method, and it will, as soon as my singleton class is loaded, all the static variables will get the memory assigned. So the object of my singleton will be created and the same object will be returned here. Okay. So let's do the same thing for the obj2. And when I'm going to run this program, you will be able to see constructor is getting called only once, and the hash code of both of the obj1 and obj2 is same. It means it is actually now creating only one instance and returning the same instance every time. And why it is not creating multiple instances? Because now my obj is actually a class variable. You can see it is a static, and statics are always class variable. The memory for a static variable is allocated at the time of class loading, and it is associated with the class. It is not associated with each instances of that class. So that's why having a static object of the my singleton class, I am able to complete my singleton design pattern. So this is one of the very basic example of creating a singleton design pattern example. But there are some problems in this. Actually, I will not say this is there are some problem, but this way which we did is called eager loading. And why we call it as eager loading? So I have mentioned like eager. Why we call it as eager? What is the problem with the eager loading and what we are going to learn next? Let me explain. So first of all, let's understand the problem. So let's say I have a public static integer a equal to 10, and here I'm gonna remove all this line and I'm just gonna write so hello. So what do you think what will happen? So it will obviously print hello, right? So you can see on the screen that it printed hello. In the my singleton class, I have a constructor where I have written like constructor called, but it was not printed because I have not used singleton class yet. My singleton class, I have used only main class, and it printed hello. But what will happen instead of hello? So let's say I am printing my singleton.a. So the value of my singleton.a is 10. So ideally it should print 10. But let's see what will happen. So once I click run as Java application, you will see constructor called in 10. So now the interesting thing is I've just printed my singleton.a, but as soon as I used any of the static variable of my singleton class, the class gets loaded into the memory, and the memory allocation for all of the static instances will be done. So that's why you can see that even I have printed only a, this line also gets executed. The memory of this is also gets allocated, and that's why this constructor call is also happening at the same time. So even if we are not using the actual object of our singleton class, it is still allocating the memory. That's why we call it as eager loading, that even if we are not using it, it is actually allocating the memory. So this is obviously not a good way. Now, what we can do to prevent this? The solution is very simple. Instead of creating object here, I'm gonna remove this. And here in my get instance, what I'm gonna do, I'm just gonna write something like this. If obj is equal to null, then obj equal to new my singleton. So as soon as I write this, what will happen? So when I run this program, output is only 10. There is no constructor called. And why so? Because let's go back to my singleton class. Memory for both of the static variable gets allocated. Yeah, it's allocated, but this object default value is null. And we have removed the new keyword from here. That's why the actual memory allocation for the object will not occur. Only the memory allocation for this reference variable will occur. So that's why it actually prevents the memory allocation at the time of just loading. But now let's get back to original part. So what I'm gonna do here is, again, same right lines of code. I'm creating two objects by the help of my singleton.get instance. So what will happen whenever first time it will come to this line, my singleton.get instance, what will happen when it will come first time into this method, object default value is null. Okay, so it will go inside this object equal to null. It will create a new object and it will return the object. And it will print a hash code. Again, we will try to my singleton.get instance, but next time when it will come to this method, the object is now not null because we have already allocated the memory. We have already this line has already been run, so now the object is not null. In that case, it will just skip this check after, because this will return false and it will directly return the same object. Okay. So in this way, if you will run this program, you will see the same output where you can see constructor gets called only once and the two objects obj1 and obj2 have the same hash code, which means actually it is only one instance. So this is the second way of the my singleton class, the singleton pattern. One is what like one I showed previously, that was eager loading, and now which this one we call it as a lazy loading. It means that memory will be allocated only when we will actually use it. Okay, so here as of now we have covered the two ways. Now in the next section we are gonna learn one more problem. There's a very basic interview question. As soon as you will create this program and present it to the interviewer, the next question which will come to you is your program thread safe? Is your design singleton design pattern thread safe? So first of all, let me tell you the answer. So okay, answer is no, it's not thread safe. And why it is not thread safe, what will happen, that we need to understand. Okay, so let's say we are having a multi-threaded environment. Let's say we have two or multiple threads, and in both threads calling get instance at the same time. Now in the get instance method, one thread goes inside this obj equal to null. It, let's say t1 thread goes inside obj equal to null. It's a true, and it goes to line number 14. In line number 14, it is going to create a new instance, but just before that, thread 2 also comes to the same line if obj equal to null. And at this moment of time, obj is still null because t1 has not created an instance yet. So in that case, t1 and t2 both are inside this loop, inside this condition, not loop. So on line number 14, if both thread reaches to the same point of line number 14, in that case, the two instances of this will be created, which will actually cause the problem. So in case you don't get it or you don't understand it, you first of all need to learn some basics about the multi-threading concept in Java. And I'm just not explaining this theoretically. I'm going to do a practical where you can see that how it is actually creating a problem in a multi-threaded environment. So let's say I will go back to main.java and I'm gonna comment this piece of code. And what I'm gonna do, I'm gonna create a runnable, and I have written like task. And what I'm gonna do it here, simply I'm gonna do the same thing which I was doing here. So I'm gonna print like my singleton dot get instance dot hash code. Okay. After that, what I'm gonna do, I'm gonna create array of thread. Let's say I have given name tr and I have created like new thread. But let's say I'm creating array of 10 elements. Now I'm gonna create something like int I equal to 0, to I is less than equal to 10, I plus plus, sorry, I plus plus. And here I'm gonna do tr I equal to new thread, and bracket I'm gonna pass this runnable instance to task. So just in case if you don't understand this syntax, it's lambda introduced after Java 8. So you can also uh, use the conventional way of creating a enable interface. So you can create a new class, implement that enable interface, and override the method. But I'm not going to explain that part in this video. But what we are going to do, I have created 10 threads with the same functionality where we are just gonna create instance. We are gonna get the instance using get instance method and print the hash code. And right now I have just created the thread. I have not started the thread, so I'm gonna create another loop. And in this loop, I'm just gonna do tr dot start. So when I'm gonna run this program, let's see what will happen. So, okay, so it is giving array out of index because I have written less than equal to. Let's remove equal to here because it will run from 0 to 9 only. It should run 10 elements as 0 to 9, not 0 to 10. So I'm gonna do it again. And let's see what will happen. Oh God. So it is now calling constructor called, constructor called, constructor called, multiple time constructor gets called. And every time you can see a new instance, new hash code. So this is the problem. So now you have seen that how in a multi-threaded environment, my singleton design pattern class is also not working properly. It has created multiple instances of the same object, the same class, multiple instances, right? So in this, when I run this, you can see all these 10 instances have different hash code, but this will not be guaranteed. You can see like only two instances have same hash different hash code and rest may be same, so it will be totally random. It totally depends on that how many thread will actually go inside this line at the same moment of time. So just in our case it is happening for all 10 threads. That's why you can see if in different. So now you have seen that in how in multi-threaded environment, what is the problem exactly, how my singleton class is actually not working as a singleton. Now we will go to the part of the prevention, that how we can prevent it. So if you know about properly about a multi-threading concept in Java, you will automatically know the answer, how we can prevent it. And the answer is very simple. We just need to make sure that this line, whenever this line gets executed, if one thread is executing this, another thread should wait. So not this line exactly, this line, it should wait. So even I will start with an even simpler way. So what I'm going to do, I'm just going to put one synchronized keyword here. So as soon as I added a synchronized keyword with this whole method, what will happen? This method is synchronized. It means as soon as one thread will call this method, first of all, before going to the inside the method, it will create a lock. It will take a lock on this method. So for example, T1 reaches to this method, T1 calls this method. First of all, it will lock the method. If any other thread will try to access this method, it has to wait until and unless T1 completes its execution of this method, right? So just adding a synchronized keyword here, it will resolve our problem. So now I'm gonna run this, and now you can see constructor called only once, and all the 10 instances have same hash code. So actually, this is only one instance. We were not 10 instances, right? So this is one of the way of resolving our problem. But there's again next question from the interviewer, which usually they can ask, that is it a right way, or isn't there be a better way to achieve this? Now this is something I call it a tricky part, because I don't believe that there's any problem in this code. But let's say, just for the interview perspective to understand it, let's say we have some lines of code here. Before this, maybe we have 10 lines of code here, 10 lines of code here. So do we really need the complete method to be synchronized? Do we really want that if one thread is executing this method, every other thread needs to wait? The answer is actually no. We just want only this block to be synchronized. We just want only this block to be synchronized, so that no two thread will find the object equal to null at the same time. So instead of creating this complete method synchronized, I can just move this block into a synchronized block. So if you will understand it properly, I can say that if there are no piece of code here, if there's no piece of code here, it's totally fine that I am making my complete method asynchronized. But just for the sake of knowledge, this is not a good way. What I'm gonna do, instead of having this, I will do something like this. I have just removed this line. I have added synchronized block. In synchronized block, I'm gonna write my singleton dot class. And here I'm gonna add one more check of if obj equal to null. So I'm gonna do double check, and I'm gonna write like this. And I can remove the synchronized from here. So if I will run the program, first of all, let's see what will happen. So again, it is working as expected. Constructor is getting called only once. All the 10 instances are same. And how it is actually running? As soon as T1 first thread gets inside it, object is null. Yeah, object is null. It will go inside line number 14. This is also possible that line our thread T2, T3, everyone is at line number 13 at the same time. It may be possible that all of these threads gets obj equal to null at the same time. But as soon as any one thread hits this line, it will take a lock on this block of code. And as soon as first thread gets the lock, it will create start execution. It will check obj equal to null. It will create a new singleton object. Until this time, every other thread will keep on wait. It will not start the execution of this block. Once T1 completes its execution, T2 will go inside this block after taking the lock. And at that moment, obj will not be null because obj has already been instantialized by T1. So it will simply skip this block because condition will be false and it will return obj. So in this way, we have not made the full method synchronized, and we will have just made this block a small piece of code as synchronized, and it is producing the same result, that is our singleton design pattern. So now you can see that I have covered the topic where we have seen the very important interview question, where how in multi-threaded environment our singleton design pattern is not safe and what we can do to make it actually safe. Now the next topic I'm going to cover is how to break singleton design pattern using reflection API, deserialization, and clone methods. So, and how we can prevent this breaking. So, we will cover this topic with the examples. And yeah, there is one more topic which we need to cover, Bill Pugh Singleton. So let's start first with the like how to break a singleton design pattern. So I'm gonna move back to my Eclipse, and here is our singleton code. Let's keep it as it is. And in the main method, what I'm going to do, I'm now just going to remove this all this multi-threading code. And let's say I have created the first instance, and now what I'm going to do, I want to break it somehow. So the very first way which I'm going to use is a reflection API. So how I can do that? So let's say I have written my singleton dot class dot get declared constructor. So there is a method get declared constructor, and what it returns is a constructor, and let we have given the type, and I have given the object name. Constructors, my singleton constructor, so my singleton dot class dot get declared constructor. So this is a reflection API. I am going to add throw declaration. So whatever the as this method is having some checked exception, that's why I have to throw it or handle it via try catch. So I have just added throws. And now what I'm gonna do, so the using this line, what it did, that I get the constructor of my singleton class in this object. Now if I have the constructor, I can do something like constructor dot new instance. So if I click constructor dot new instance, you can see it's still giving some more exception, like unchecked exception, sorry, checked exception conditions like unhandled exception type invoke target exception. I'm gonna add div2 in my throws div, and this is fine now. Constructor.new instance. So in this way, you can see using constructor using deflection API, I get the constructor of the my class, and now I can try to create a new instance using constructor. So let's see what will happen. It will give actually an error, and let's see what is the error. It is giving illegal access exception, and it is saying that cannot access a member of class my singleton with modifiers private. So even if I got the constructor, but the constructor is still private, and as constructor is private, you cannot use this constructor outside the class. So, but what is the advantage of reflection API? If I have the reflection API, I have the constructor object, I can do something like this, set accessible equal to true. So I have changed the modifier from private to public. I have changed the accessibility, right? So if I will do again, okay, now you can see object has been created, and you can see two constructor called. So this has also created a like called of my constructor, and if I receive this in some object like this obj2, and like this I need to craft it. like this. And I can also print the hash code just to ensure that it is not the same object, obj2 dot hash code. And here you go. So you can see the hash code of the both of the instances obj1 and obj2 are different, which ensures that, which is a proof that right now using reflection API, how we actually broke our singleton design pattern. So now let's come to the solution part, how we can prevent it. How we can ensure that even with the help of reflection API, no one can actually break our pattern, right? So what can we do for this? So what I want to ensure that even if someone is using reflection API to create a new instance via the constructor, I want to prevent it. So what I'm going to do, I'm just going to do a very simple check in the private in this constructor that if obj is not equal to null, and when obj will not be equal to null, only when this constructor will be called second time or third time or fourth time. At the very first time, obj will be null, but as soon as the first time this object is created, first time as soon as that constructor will be called, you will get the new object. So in the second time, from the second time onwards, constructor, this obj will never be null. So what I'm going to do, I'm just going to throw an new exception, and I can write something like you cannot call this, or something like you are trying to break my singleton design pattern. And as I am throwing the exception, I just need to throw exception here, and I also need to throw exception at throw exception in this method, or I can use the try catch. So here I'm gonna do the same at throw exception. And now if I will run this program, you can see that as if someone will try to create a new instances via the reflection API, it will simply throw the exception. It will say that you cannot call this. So now even that using the reflection API, no one can break my singleton design pattern. So this is how I can prevent my singleton design pattern even from the reflection API. Okay, friends. So let's come to the next part. I'm gonna remove this for now. I'm gonna remove this. I can remove this. I can remove this. Okay. So the next method using which we can actually create multiple instances of a singleton class is serialization and deserialization. So if you know about serialization and deserialization, then it will be good. So serialization is just a process of converting an object and saving it to a file, and deserialization is vice versa. So I'm gonna write some piece of code with a practical example. You will be able to see it. That will provide much more clarity. So let's say what I'm gonna do here is first of all, in order to serialize any class that needs to be serializable, so I'm gonna add implement serializable here. And in my main.java, what I'm gonna do, I'm gonna create object output stream object. This is class, and I'm gonna new object output stream. Inside this parameter, what I need to provide is file output stream. Inside it, I can give some name. Let's say obj dot obj1 dot obj. So I can give any name. Extension cannot be also, you can choose any extension. It's not necessary to give obj. You can even write abc. That will also work. So after that, what I'm gonna do, I'm just gonna do oof dot write object. So what it will do, and I am gonna pass this obj1 here. So what it will gonna do, it is going to serialize this obj1 and write in a file called obj1.obj. So let's see what will happen if I would run this program. Okay, so object has been created, hash code is getting printed, and now the file should be created. So where this file is there, so I'm gonna go to my singleton example. I'm gonna click on refresh here. So let me refresh. Where is refresh? Okay, yeah, here we go. So you can see, okay, obj1.obj has been created. So in this file, my object has been derived and written. It will not be human readable format. If you try to see this, it will be something like this. So non-readable format. So I don't want to actually read this like this. So I'm gonna write a piece of code to read this file and deserialize it and create a new object. So for that, what I need to do, I need to write something like object input stream OIS equal to new object input stream in the same way we did for output. And I'm gonna write new file input stream. I'm gonna give the same name like obj1.obj. After that, what I'm gonna do is simply it's a read object method. Gonna call this read object method. So if I remember correctly, it should be OIF dot read object. Let's see if there is some method. Yeah, it's a read object. And I also want to receive this object something like this. So my singleton obj2, and I can craft this like this. My singleton. And what I'm gonna do is so obj2 dot hash code. So when I'm going to run this, you can see constructor is getting called once because the second object which we are trying to create, we are not calling the constructor. We are not using the new keyword. We are actually creating it via deserializing the serialized object. So even the constructor doesn't get called, but still you can see there are two different instances of the singleton class. So this is the second way of breaking the singleton design pattern. Now, how can we prevent this? So the answer is very easy. So in this my singleton class, what I just need to do, I just need to add another method. I just need to write public object read resolve. So this is a predefined name. You need to give this name. And here I'm returning the same object instead of creating a new object. So what will happen whenever our file will be read and deserialized at that time of creating the object from the file, it will use this method, and instead of creating a new object, it will return the same object. So even after serialization and deserialization, now you will be able to see that you are getting both hash code as same. That means only one instance is getting created. So this is the second way. After deflection API, second way is serialization and deserialization. Now we will talk about the third way, which is clone method. So third way of breaking our serialization, our singleton design pattern. Okay, so I'm gonna remove all this. I'm gonna remove read resolve. I'm gonna remove implement serializable, but I'm gonna implement another interface clonable. So if I want to clone an object of a class, that class needs to be clonable. Then only you will be able to clone it. That's why name is clonable. And if you do clonable, you also need to override a method, and the method is clone. So you just write something like override, and here you can write public object clone, and it should be choose clone not supported exception. And here you just need to write return super.clone. And here we go. And what I'm going to do is very simple. I'm just going to do is obj1.clone and receive it something like this. And print the hash code. Now I'm going to run this program. And you can see in the output of the program that both of the hash code are different. So obj1 and obj2 have different hash code, like two different instances has been created, two different memory has been allocated. Even our class is a singleton design pattern class. So there's a third way of breaking the same design pattern. So now if we want to prevent diff2, what we can do is very simple. We will just go here and instead of returning super.clone, we will return obj here so that it will not be able to create a new instance even via the clone method. So you override the clone method and return the same object. Now you can see both hash code are same. So even if you are using the clone method to create the second object, but you are still getting the same instance. So here we have covered all the three ways using which we can break the singleton design pattern, and we have also covered how we can prevent all the three ways. So I hope you will be able to understand all these concepts. If you feel any problem in understanding these concepts, please feel free to reach out to me via the comment section below. And one thing I always suggest to my students that please see this video, pause this video, try it yourself in your editor. You can use Eclipse or whatever editor you want to use, but when you will try the code along with watching this video, it will give you a better understanding. So just watching the video usually never works. Maybe you will understand the things, but if you want that you will never forget this thing, please do the practice, do the exercise along with this video. So let's move to the last topic of the video of my singleton design pattern. That is, if you remember, let's go back to the slide, and the topic is Bill Pugh Singleton Design Pattern. So this is a different way of creating a singleton design pattern. So let's get back to Eclipse and cover the Bill Pugh Singleton Design Pattern. Okay, so I'm gonna remove all this clone thing. I can remove this. I'm gonna remove implement clonable. I'm gonna remove import. I'm gonna remove. Okay. Let me do one thing. Let's remove this also, and let's go back to our eager pattern, my singleton, right? So this is what we studied like at the very beginning, the very first pattern, which is eager one. So this is a singleton design pattern with the eager, like, but if you remember that what is the issue with this pattern, even if we will not use this obj, if still it will create the object, it will allocate the memory. Even if we will try to print the value of a, it is also printing constructor called, right? So Dr. William Pugh resolved this issue in a way. So what he suggested, instead of having this line here, let's remove it from here and create a inner static class. So how we can create an inner static class is very simple. What we are gonna do, we will create something like private static class, and you can give any name, let's say folder, or you can give helper or whatever you name you want to give. And here I am gonna paste the same line, and I can also add final here. And as now my obj is inside my inner class, I cannot use obj here like this, so I'm going to use it like folder.obj. So what is the advantage of doing this? So now you will see, let's remove it for now, and let's see, I have printed my singleton dot page. So if you remember correctly, like previously when we were trying to print A, it was printing constructor called n10. But now you can see it is printing 10. So with this pattern, which we call as Bill Pugh pattern, memory initialization is not happening at the time of class load, because class is getting loaded into the memory, but if still we are not actually allocating the memory, because right now it's inside this static class, this inner class, right? So the Dr. William Pugh method resolve our problem. It solves our problem of eager loading. Now we need to see that does this solve our problem of multi-threaded environment? So if you remembered, the actual problem why our singleton pattern was not working in multi-threaded environment without the synchronized block or synchronized method is the if condition. So we were checking if obj equal to null, and if more than one thread goes inside the same if condition at the same moment, it was actually causing the problem. But right now there is no condition, there's no if condition. So this method of creating singleton design pattern is already a thread safe method. But to prove my point, I'm gonna use the same way what we have used early. So I'm gonna do undo, control Z, and let's see if I can get the same. Go back. Yeah, here we go. So here, as we did earlier, I have created 10 threads, and I am gonna do run as Java application. And here you can see constructor is getting called only once, and all the 10 instances are same. So with this design pattern, which we call as Bill Pugh pattern, it is not creating any problem of eager loading. It's actually doing lazy loading, and it is also a thread save. So this is also a very common interview question, and it is one of the very advanced way of creating my singleton, like our singleton design pattern. So I hope you understand all the concept which I have explained in this video, and I hope that you would have liked this video. In case of any question, please feel free to reach to me via the comment section. And please, if you like this video, please click on the like button, subscribe our channel, and reach out to me via comment section. Thank you, friends. We will meet in the next video with some other design pattern. Thank you.